Let's see question number 9. In figure 6.45, ABC and AMP are two right triangles, right angled at B and M respectively. Okay, so we have two right triangles here. Triangle ABC, this triangle, right angle at B, 90 degree here, and triangle AMP, this triangle, right angle at M. Now we have to prove that triangle ABC is similar to triangle AMP. Now we're going to prove that this triangle ABC is similar to this triangle AMP, this triangle. And also we have to prove that CA by PA is equal to BC by MP. Okay, let's see how to prove this. To prove is triangle ABC similar to triangle AMP. This is the AMP, this is the first one, and the second one is CA by PA is equal to BC by MP. Now proof. This is a very simple question. We can easily prove this by using AA similarity, angle similarity. Now in these two triangles, let me draw it here. This is the first triangle, A, B, C. Here this is 90 degree. We have 90 degree here. And the second triangle is this triangle, AMP. Now this is the second triangle. Now in these two triangles we have 90 degree here, and in this triangle we have here 90. So we have 90, 90. So let's write in triangle ABC and triangle AMP, angle ABC is equal to angle AMP. This is, since each of them is 90 degree. Now this angle A is common to both the angle. This angle A is for this angle, triangle ABC, as well as for triangle AMP. So we're going to say here angle A of the first triangle is equal to angle A of the second triangle. So this is a common angle. Now we have two angles of the first triangle, that is triangle ABC, equal to two angles of the second triangle. So therefore we can say that these two triangles are similar. Triangle ABC is similar to triangle AMP. This is by AA similarity, angle similarity. Now since these two triangles are similar, the corresponding sides will be proportional. So the corresponding sides of CA, this AC, CA, therefore CA, or you can say AC, CA. Since we're taking this one and this one here, we'll take this one and this one. So the corresponding sides of AC will be AP, or you can say PA. PA will be equal to the corresponding side of BC. The corresponding side of BC is MP. The corresponding side of BC is MP. How to take the corresponding sides I have already explained when we were doing this concept of this chapter. So there we have learned how to name correctly similar triangles. And now once you have named the triangles which are similar to each other correctly, then you can take the corresponding sides just by looking at the names. So corresponding angles and the corresponding side, you can find it out by just looking at the names. So here the corresponding sides of AB will be AM, the corresponding side of BC is MB, and the corresponding side of AC is AB, or you can say CA is PA. So this is how this is what we have to prove here in Roman number 2. So we have got both the proof. This is the first one and this is the second one, so hence proof. Now let's see the next question. The next question is CD and GH are respectively the bisectors of angle ACB and angle EGF, such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC is similar to triangle FEG, show that. Okay, these are the things that we have to show here. And here in this question, figure is not given, so we have to try to figure out the figure by ourselves. So let's see how we can draw this. Now we have two triangles here, that is triangle ABC and triangle EFG. Triangle ABC, triangle ABC, A, B, C, and the other one is triangle FEG, F, E, G, and CD and GH are respectively the bisectors of angle ACB. So CD is the bisector of angle ACB, so we have angle ACB here, this angle. So we're going to bisect, we're going to divide into two equal parts, that means two equal angles, so this and this. So this is the bisector, CD is the bisector of this angle ACB, and GH is the bisector of EGF, this angle. So the bisector of this angle is this one. We are going to divide into two equal parts, so this and this. GH. Now this is what is given in the question. Now we have to prove this this given three things. So let's write here. To prove is question number 10. To prove is number 1, CD by GH is equal to AC by FG, and then number 2, triangle DCB is similar to triangle HGE, and the third one, triangle DCA is similar to triangle HGE. Proof. Now let's say this is 1, 2, 3, 4. Now here it is given that triangle ABC is similar to triangle FEG. Here we have triangle ABC similar to triangle FEG. This is given. Now since these two triangles are similar, so this angle A will be equal to angle F, which is this angle will be equal to angle F. So angle A is equal to angle F, and angle B is equal to angle E. This angle and this angle. Angle B is equal to angle E. Let's call this 1. Let's call this 2. And also angle C is equal to angle G. Angle C is equal to angle G. Angle C is equal to angle G. But now in the figure we have a bisector here, CD. So here one thing we can do is half of angle C is equal to half of angle G. Now if two quantities are equal, then their halves are also equal. So since angle C is equal to angle G, half of angle C will be also equal to half of angle G. Now this angle 1 is half of this angle C, angle 2 is also half of this angle C. Since CD is the bisector, which means CD has bisected, has divided this angle into two equal parts. Now we say that angle 1 is half of angle C, angle 2 is also half of angle C. So here half of angle C we can write here angle 1, and here half of angle G. Now this angle G, which is the whole angle, has been divided into two equal parts, that is 3 and 4. So 3 is also half of G, 4 is also half of G. So half of G we can write here 3, angle 1 and angle 3. Or you can also say here half of angle C you can write here 2 equal to, or you can just write here angle 2 is equal to angle 4. Now let's call this 3 and let's call this 4. Now what we have to prove first is that CD by GH is equal to AC by FG. So here let's try to prove that one. Now to prove that, let's see where this CD and GH are. Okay, CD by GH is equal to AC by FG. AC by FG. So this and this divided by this and this. So that means we have to consider these two triangles. Now let's see whether we can prove that these two triangles are similar or not. Now from equation 1 we have angle A is equal to angle F here, and again from equation 4 we have angle 2 is equal to angle 4. So that means two angles of this triangle are equal to two angles of this triangle. So therefore we can say that by AA similarity these two triangles are similar. So let's say that one, in triangle DCA and triangle DCA and triangle HGF, angle A is equal to angle F, this is from 1, and angle 2 is equal to angle 4, this is from 4. So now we have two angles of the first triangles are equal to two angles of the another triangles. So therefore by AA similarity triangle DCA is similar to triangle HGF. Now these two triangles are similar now. Now since the two triangles are similar, now the corresponding sides are proportional, that is DC by HG. So you can write CD, no problem, CD by GH, this one and this one, that is this side and this side, is equal to AC, this two, AC by FG, because these are corresponding sides. So when two triangles are similar, the corresponding sides are proportional. Here again we can write equal to AD by FH, but we don't need that. We just need to prove that CD by GH is equal to AC by FG. So this is the proof for the first one. Now let's see proof for the second one. Now Roman number 2 is we have to prove that triangle DCB, this triangle, similar to triangle HGE. Here also, in these two triangles also, we already have that these two angles are equal, and angle 1 and angle 3 equal. So by AA similarity, we can say that now these two triangles are also similar. So let's write here, in triangle DCB and triangle HGE, angle B is equal to angle E. This is from equation 2, from 2, and angle 1 is equal to angle 3. Angle 1, this angle is equal to this angle. This is given here. Angle 1 is equal to angle 3. Angle 1 is equal to angle 3. Now two angles of the first triangle is equal to two angles of the second triangle. Therefore, by AA similarity, these two triangles are similar. So therefore, by AA similarity, angle similarity, triangle DCB is similar to triangle HGE. Now this is the proof of the second one. Now the third one, here triangle DCA is similar to triangle HGE. This third one we have already proved in Roman number 1 here. Here we have already proved here. For the third one, you will say, as proved in 1, triangle DCA is similar to triangle HGF.